Welcome everybody to part 12 of the ESTeem wireless training class. This is actually our last section that we're going to be covering, and we're going to cover the items that go into installing, troubleshooting, and maintaining a wireless network. There are many things that elements that go into this, and what we're going to cover in this section is those elements that you will continually use again and again. You'll find here, as we're going through this, we've already learned many of the tools that we need to maintain a wireless network over time. What we're going to do now is put these into an order to where hopefully they'll make sense, to where you can go back into the radio and find exactly where the significant information you need to pull out to maintain and keep a network running. So let's go ahead and start with the first section, which is really the installation of it. Now, almost every one of our radios has the possibility to do what we call a pole mounting. That is something that we covered in 2 or 3 different sections of the training class so far. What this is this gives the ability to where the radio is either directly mounted to the antenna to eliminate the coax cable, or we install a small little jumper piece of coax between the antenna and the radio to eliminate out as much signal loss as we can possibly do. Well, to do that, we've actually put together what we call a pole mount kit. Is our part number AA195PM for pole mounting kit. The idea behind this is it has all the pieces and parts that you would possibly need to make a Horizon series radio mountable, either directly to the antenna or below it, out in the weather, outside, so that when this is all done, it's actually NEMA 4 compliant. The first thing that we always recommend doing is unpacking the box, inventorying all the items in there, making sure that you have all the pieces for that pole mounting kit. We have 2 different ways. We actually have a technical bulletin that goes through the assembly procedure step by step on all the items that you should find within the pole mounting kit, where everything goes. We also have that exact same technical bulletin inside of the user's manual. So it is available in many different formats to it. The idea behind this is the pole mounting kit allows us to mount the radio either onto a piece of conduit anywhere between 1.25 inches to a 2.25 inch outside diameter piece of conduit or pole. Anything that's larger than that, there are actually essentially slits in the pole mount kit that allows you to add a strap to it. So you could actually strap it up the size of a telephone pole, really, if necessary. The other component that we have inside of there is what we call a solar shield. Let me give you an idea of what the components I'm making reference to here. Going kind of from the top here, we actually have a cover within the radio. It's actually designed to take a standard RJ45 connection. And again, what we do is if it's an outdoor mount, we usually use a specific type of cable. It's an outdoor shielded UV protected cable that allows you to just use a standard metal hooded RJ45 connector so that we can solder at the upper end on the shielding, and at the lower end allows us to connect that into the surge protector. And we've got some diagrams here in a couple slides, so we'll see how that goes together. But the cover allows us to mount either one, or you'll see a second one here. It's got a little black cover on, a little black rubber cover. Then that can go off if you've got 2 Ethernet cables, or we might have an Ethernet and a serial cable. But we can actually run 2 different cables into that radio up that pole, and both of them will actually go inside of that cover. The mounting kits that actually that go on the back of the radio are these particular units. And as I mentioned to you, these are designed to actually go with these pieces that you see over here that go in with the U-bolts that allow it to go into a normal pole mount. So you would have it in kind of a configuration crudely like this. If that doesn't work, you see here, it's kind of hard to see on this, but there are actually 2 slats inside of there that you can actually put just a metal strap throughout the base here, and it can actually then go around and go to a much larger diameter connection if necessary. So it is very convenient on the way that this can be mounted. All of these kits will actually come together. The main pieces you'll see are the cover, the solar shield, the two mounting kits, and then all of the accessory pieces. And we have pieces in there for two different direct mount antennas that you see listed here, and covers for the two Ethernet connector too. Anything that isn't going to be used, in other words, if you're not going to use Ethernet cover, we put a plug in there too, so that there are no open holes available once this is actually installed. Again, we have this kind of laid out in much greater detail. We're actually going to have a video on how to actually put this together also. So what does this actually look like? Well, this actually covers what we'll call two different elements of our normal installation for our Horizon series radios. This one, we actually break this out into what we call direct mount, where the antennas are physically mounted to the radio itself, and then you use the weatherproof boots actually fit over the outside of those to make it weatherproof at that point. We also have an external antenna mount. It's either going to be either with an omnidirectional antenna or directional antenna, or we also have a standard what we'll call a cabinet mount, which is the most common type configuration for just about every radio in the world that does this, where you've got a remotely mounted antenna, cable come down. The Horizon series radios, or any of our radios, can actually fit into just about any of these type of applications. There are radios like the 210 that can only be mounted cabinet mount. Most installations for the 195 narrowband series are cabinet mount, but they do all kind of fit within this configuration that we see here on the right. This is kind of how the pieces and parts go together. Everything that you see here that has a little asterisk by it, it may be a little hard to see on this graphic. All of those are actually the components of the weatherproof. As you can see here down from the picture, on a direct mount assembly, this is what it would look like when everything is done. Now, it may seem a little strange that we put this metal plate over the radio. Well, what this is actually doing is that this is actually a solar shield, because we do have a black case, and it is a carbon fiber based case, so it is electrically conductive. So what we do to allow some extra airflow through it is we actually have this solar shield that we put over the top of it, and it allows an air gap in between that and the case. So that temperature difference between the two, as the sun's beating down on the solar shield, will actually draw air across these cooling fins on the front of the radio and help cool the system down. Now, as a comparison to that, the only thing that changes is when we go into an external mount is the antennas themselves. We are no longer going to mount them directly to the radio, so they actually come with a small little piece of coax in both, whether we're talking about panels or omnidirectionals or even Yagi antennas in some cases. And all of those antennas that we sell in this kind of configuration already have the weatherproof boot on there. So it's not something that you're going to need to disassemble and put the weatherproof boot on. It is all a component of it. Same thing for our PoE Ethernet cables, as you see listed here. The Ethernet cable already have the weatherproof boot. It'll already have the soldering and the connector down at the base. And as I mentioned to you down at the lower end, the way that this works into the surge protector is the Ethernet cable actually gets clamped inside of the surge protection device, and then that shield comes off of the radio, which is just wrapped around the outside, and it goes to earth ground. The surge protector and the shield go to the same earth ground potential to make sure that if anything, either as a nearby strike, basically a buildup of energy on the case itself, allows it to pass to earth ground without damaging the radio. These radios can also be mounted in what we call kind of a classic enclosure mounting, which is what you see on most every radio system, to where you've got a remotely mounted antenna, either omnidirectional or directional, and then we've got a coax cable that runs into a lightning arrestor, and then we have a jumper piece that goes from the lightning arrestor into the radio. There's no problem in mounting it this way. The only difference is that all of the cable that you put in here between the radio and the antenna, that is going to give a signal loss. So the more we can eliminate out that signal loss or minimize it, the better off the system is actually going to operate. Now, a good place to start with this is, how do we troubleshoot this? What do we do? Well, not to oversimplify it, we've really broken this down into 5 steps. Now, what happens in most control systems where these radios are applied, what you're going to find is all that the communication tells you, all the system is telling you is that you've lost a remote site. It really does not pinpoint to where exactly the problem is, unless you've already integrated, as we saw on the last in the last section we went through, like say a Modbus TCP, where you can see that the radios are communicating or with the signal strength. In most cases, you're going to go out and find that all we know is the customer tells us we've lost this site. So what steps do we go through to make sure that happens? So what we've done is we've put this into 5 very simple troubleshooting steps. The first thing that we do is just verify, do we have Ethernet communication between the computer that we're doing the troubleshooting on and the radio itself. Something may have happened to the Ethernet port on it. It may be set to a different IP address. Something is configured that way. This may be as easy as putting in the Discover utility and pushing the Discover radios button and see if the radio replies back to it. If we verify that we've got communication to it, then what we're going to do is we're going to open up that radio either through the web interface or through the ESTeem networking suite, which we covered in our last section, the programming software, and verify that something hasn't changed within the configuration of the radio. It is very possible, as people are doing remote troubleshooting, maintenance on it, they get in there and change the configuration of a remote. It's not unheard of that you accidentally set something to the wrong destination, IP address, could be just about anything. If all of that still looks good, then what we want to do is we want to check the antenna and the cable. Now, really, this is going to come down to how the radio is installed. If it's a directly mounted antenna, there really is no cable to check, but what you can do is take the antenna off, verify that there is not corrosion, oxidation, any kind of contaminant between the center conductor on the connector and the center conductor in the radio itself. Because what we're talking about is physical contact between 2 pieces of metal. So if we have anything that gets between that, it is going to cause a signal loss. If all that still looks good, or even on the external mount antennas where we have a small little piece of cable, verify that the cable has not been cut, verify that it has not been crimped, that there's not any damage to it. Most of this can actually be done through a physical inspection. If we've got a longer piece of coax within the system, therefore we're going to measure and test the SWR, the standing wave ratio, or the forward reflected power, which we covered in earlier sections on how to do that. What this is doing is verifying that there is no problem in the coax cable and the antenna. If all of that looks good, and all the power output on the radio still looks good, then what we're going to actually do is take a look at the received signal strength. Now, we get into the received signal strength there are a couple different ways to get into it. You can pull it up through the WDS link monitor, which we saw in an earlier section in the discovery. Most of the troubleshooting is done within the web interface, and we'll get into much more detail of that in the next couple slides. But what this does is we're verifying that we're actually receiving information coming, what we originally started with, because the problem may not necessarily be at the site that is showing up that has a problem. It may be at the site that this one is actually communicating to. If we're verifying that the signal strength hasn't changed, then what we can do is we can really just run data over the top of it. This may be as simple as running a simple ping test between the computer that you're plugged into that radio and the other radio itself, or a connected device to that. Just verifying that those 2 radios are exchanging information back and forth. If all of that looks good, the problem is not in the radio system. We need to continue troubleshooting outside of the radio system. Now, this may seem like an oversimplification of things, but really what we're doing is that, as you notice here, these are the exact same steps that we performed when we did the radio site survey and we did the radio commissioning back earlier part of the training. These are the exact same steps that we go through every time that we want to look at how a radio is working, and if it is if the problem is in the radio or outside of the radio. Now, the reason that we have them in this particular order is the fact that if you look at here, if we wanted to immediately go and figure out, well, why don't we just check to make sure the radios work? Well, you could do that. You could actually go in and just try a ping test. The problem is if you don't have a ping test, you're not getting any response, well, you're going to start backing things up. Well, is the problem in my communication to the radio, back with the direct Ethernet communication? Is the problem actually in the configuration of the radio? Do I have a problem in the antenna? What these are in these particular order is these are additive. To get to step 2, you need to complete step 1. It needs to verify it. To get to step 5, we need to have 1, 2, 3, and 4 operating and working correctly. So that's why they're laid out in this particular order. If you can remember these 5 simple troubleshooting steps, this is going to point to where the problem is within that communication network. So what are some of the tools available to us? How do we look at the received signal strength? How do we look at where to find this? Well, the radio itself actually has several different status menus available inside of it that are going to point you where the problem potentially lies. So we actually have 2 different status menus within the horizon, one for the CPU status that gives us the uptime of the radio, the date, the time, what's happening within the CPU and Ethernet status, how many frames coming in, how many going out, how much available memory. It also has internal temperatures. So if we're running too hot, and that could potentially be a problem, that's an easy place to look for it. The idea behind this is the only time you're really going to get into the CPU status is really when we, from the factory or troubleshooting through it, will generally ask you for some component out of that. Most of the troubleshooting, primarily on the wireless side, is of course going to be done what we call the wireless status page. Now, the wireless status actually breaks down into really multiple menuing systems. The first one is that how are the devices that it's communicating with connecting to that radio. So if we're going in and we're looking at a access point, the access point is going to list out those what are called associated stations. Now, associated stations are going to be mobile devices. They may be other ESTeams programmed into one of the station modes, the ether station, station bridge, station router, station masquerade. Those will show up in the associated stations. Wi-Fi connected devices for our 2.4 gigahertz and 5.8 gigahertz radios are going to show up under associated stations. Those that are other access points in the network, and we've configured them as peer links, are of course going to show up under the peer links. So most fixed location troubleshooting is actually going to be done under the peer link. Now, it actually will show multiple radios. So if this one radio is connected to 4 others, they'll all just be listed one right after the other. They're going to be broken down by their MAC address. Each one of them is going to have a signal strength associated with it, and we also will see where it's very powerful to actually input the modem ID for each one of the sites to kind of help troubleshooting. All radio activity is also be listed by what's happening on the access point page and also the unassociated entries. So instead of looking at this in kind of an abstract, I've got kind of a screenshot here of how this breaks down. I think it's going to be a little more beneficial really if we actually look at a live page. So using the radio configuration that we actually completed in the last section to where we have one master and one remote, what I'm actually going to do is go live into our master radio. Now what I have here is 2 Horizon 900 megahertz radios. They're already pre-configured. We actually configured them through the ESTeem networking suite yesterday into a point-to-point configuration. And what we're looking at is we have a master and a remote are the 2 names that we've given to them. So as you can see here, right immediately under the radio ID, we actually have master. So we know which site we're actually talking to. So if we look under the CPU status, we see here all the information that we talked about, the internal temperature of the radio. And again, this is what's happening at the board level. It's not a temperature sensor as an outdoor. And generally what we'll find is that the internal temperature can be as high as 10 degrees higher than the outside temperature. So as long as we're within the ratings of the radios, the internal temperature may actually be a little bit higher than that, but that's not something to be concerned with unless we ask to specifically look at that as far as troubleshooting goes. It also has the uptime. How long has the system been operating? We look at the memory status. You can see here that the radio itself, the CPU, is essentially running idle because there really is not a whole lot of traffic going on between the two. So it's running at 98% idle. These are the things that we'll look at as far as the pageable memory. And it also gives you information as far as the SSID of the radio, if it's accepting wireless peers, how many transmit and receive frames go into this. This fine level detail is really not something you do on a day-to-day troubleshooting. The one where we're going to do most of our work is actually over here in the wireless status. So if I click on the wireless status tab, as I said, it's really broken down into multiple sections. The associated stations, which are going to be our mobile clients, or in a Wi-Fi radio, those are going to be the Wi-Fi connected devices also. We also have peer links, which we've configured for other access points. We have access points that'll show all the other radio activity that are operating on that frequency that can be associated. So this is a 900 megahertz radio. So this particular radio is only going to pick up other ESTeams. We have to be able to pick up the header. But in a Wi-Fi based radios for our Horizon 2.4 and our Horizon 5.8, it will actually list all the other Wi-Fi access points that are beaconing that happen to be on that particular frequency that the radio is programmed for. As you can see here, because I'm talking to another access point, the same information is actually duplicated here. We're seeing both an access point and a peer that are at the same location. We also have a block in here for uncategorized entries. These are the type of devices that are going to be on the Ethernet side that don't tie towards a wireless system. And since we've got a very small network here for our training class, I don't have any other uncategorized entries. So what does this actually tell us? Well, the key here, since we have one other wireless LAN peer, as you can see, the radios are communicating, as we learned in earlier sessions, we're actually communicating at the MAC layer. So the radio is actually connected to the other radio by its wireless LAN MAC address. Again, is that very helpful? Well, if you've got a kind of a cheat sheet for it, yes, you can do that. You can definitely go through there and find it. But that is really the key to putting in the radio IDs, because as you can see, it humanizes these numbers and puts it into an actual alphanumeric thing that we can find. So we know that this MAC address is associated with the remote radio ID. Now the signal strength that we have here has both, we see here as an antenna 1. Being a Horizon 900, there is only one antenna. This signal strength is actually listed in dBm, or decibels based upon a milliwatt. The reason that we kept it in that unit is that's the same unit structure that most spectrum analyzers operate in, is in dBm. The next one is, what is our last receive? This tells us what is the actual RF data rate the two radios are talking at, and the time that it received its last packet. Now, as you notice here, there are no changes happening within this radio right now. What that is that this is actually a static page we're actually looking at. So if we wanted to look at an updated view, we actually can come up here and just hit the reload of the page, and we'll see here that, again, the signal strength isn't changing that much, but now we've actually got an updated view. So keep in mind, as you're going through this, if you're trying to adjust the antennas and you're looking for the highest available signal strength, you're going to have to keep hitting a refresh on this page to get an updated entry, or try to look in another element, which I'll show you here in just a second. The next thing it tells us is, so if you're seeing any number in here that is greater than 0, really what this is telling us then is that we have not heard from that in X number of seconds. So in most active communication, 0 represents from anywhere between 0 and 1 second. So most of the time you'll see an active link always be sitting at 0. So that's saying that we're looking at an updated status information packet, and this one's currently running at 36.1 megabits per second, which actually is the highest data rate. The reason that this radio can't actually go up to 72 megabits per second, but we're only using a 10 megahertz wide channel, versus the 20 megahertz wide channel to get all the way to 72. So 36 is the fastest that this radio can go. It tells us our SSID and of course the port forwarding state. So as we looked at when we were going through the meshing portion of it, if you have multiple links within the system and you're going on one link and you have a secondary link out there, you'll be forwarding on the link that you're using as the primary path, and the other one will actually be listed as blocked. So this will actually tell you within a mesh who is talking across the lit network. And as you see, this information is actually just replicated down below. So what we can do is if we get an updated page here, we can see here that we're always staying within 1 or 2 dB. Now, just for demonstration purposes, what I'm actually going to do is I'm going to take and I'm going to pull the power to my remote radio. Now, as soon as I do this, what's going to happen is my local radio is going to lose the communication link to it. And as you can see, as I refresh the page, the time is going to show up here as an increasing value. So what this is telling us then is that the last packet that we received, although it was at a -48 and running at a 36 megabits per second, we have not heard from that remote site in 14 seconds. So we've actually lost communication to that remote, although we're still seeing a signal strength and a data rate. Now, as soon as that comes back, what I'm going to do is, as we'll see here, we got all the way up to 40, and we can increase it. I'll plug this back in. Now, what it's going to do is it's actually going to take about 45 seconds to reboot. So during this time, let me go ahead and jump back over here to the slides and show you if you've got a radio that actually has multiple antenna ports on it. What you'll see listed here is you'll not only have an A1 for antenna 1, but you'll also have an antenna 2 listed there. So it will actually show you the signal strengths on both antenna ports. So as this particular one actually has an associated station attached to it, which is a Wi-Fi client, and here is a peer listed there also. And then again, this one happened to be on a Horizon 2.4 gigahertz radio. So as you see here, there are multiple types of other Wi-Fi available, and they list them in here by signal strength and by SSID. If it happens to be another radio, then we're broadcasting the modem ID within that system also. So let me jump back to our page and see if we've actually got our remote back in operation. So what I'm going to do here, and as you can see here, we still have the same amount of data. Now if I hit refresh on the page, what's actually going to happen is this number is going to continue to increase until that remote modem gets done rebooting, gives us an updated status, and as soon as it does that, that time will actually go back to 0 again, which tells us that we have a currently refreshed page. So I'm going to continue to do this. While we're waiting for this to come back up, the next thing I'll do is show you if we are programming through the Discovery utility. If I hit the Discover, both radios should show up, and I'm only connected physically to one of these radios, so the other radio is actually showing up through the wireless bridge link that we have established here. So if I click on my master radio, we know the remote is rebooted because we're picking it up here on the list. But now if I go down under the advanced, we go to WDS link monitor. And what this will do is now we see if I bring it over here to the screen, we actually have a WDS link monitor and it is active. So what this is doing is this is going out within every, I think this one is actually set to 2 to 3 seconds and actually actively polling it. So what I'm going to do is I'm going to reach over and I'm going to physically grab the antenna, which should attenuate the signal. So our signal strength should actually drop. So as you can see here, our signal strength is lowering. We're all the way down to a -60 now. So if I then take my hand off of it and put it back on the table, we'll go back to what it was actively communicating with. So as you can see on there, we can use this as an actual active element within our troubleshooting. So if we need to align an antenna, we need to get something working to where we need an updated block of information, then WDS link monitor is a great way to run that. That's the same type of information that you would pull out if you pull up the Modbus TCP packets and brought that into your HMI. It's the same type of information. All right. So how do we analyze this? What are the things that we're looking for? Well, again, keep in mind the radios are going to be listed by their wireless MAC address. So if you look on the back of the radio, you'll see that there are actually two different addresses listed. There's a wireless MAC and an Ethernet MAC. Because again, we have two Ethernet devices available to us. So the recommendation then is always to use the radio ID if possible, because it associates not only that wireless MAC address, it associates it with a human element, which is a name. The received signal strength is going to be listed in dBm. And again, what you're looking at is these are all generally going to be negative numbers. So because we are dealing with negative numbers, the smaller the number, the closer to zero we get, the greater the signal. So a minus 90 is a significantly larger signal, or excuse me, a significantly lower signal than say a minus 70. So you need to think kind of backwards in the way that the numbers go. So this really what it comes down to, the more noise in the area, we need more signal to overcome that. Because we are dealing with a static page, we always want to make sure that the last received signal has an updated packet. Now we can actually look at two different type of packets within the radio. By default, the horizon will actually always show the data blocks. You can actually configure it so that the radio will show both data and beacons. The reason that we turn that off by default, the beacons always go out at a fixed data rate. So for the Horizon series radios, that's actually at a 6 megabit packet. So every time that you'd hit refresh on those, unless it happened to capture a data block, it would show at 6 megabits. Because again, we're looking at kind of a snapshot of it. So what we do by default is we actually put it so that you can only look at data rates. This is actually configurable within the advanced configuration. The key to this overall, though, is making sure that you have an updated packet, that the one that you're looking at is sometime between 0 and 1 second is kind of a normal rate. Now, when we look at, say, troubleshooting of a mobile client, it is a little bit different in the fact that different modes of operation have different ways of accessing it. So for example, the station bridge, station router, and station masquerade, they all have a web page. They all still have an IP address associated with it. So you can actually log into those IP addresses of those radios and look at the received signal strength. Now the ether station, because it is a specialized mode of operation that clones the connected device, what it does is it actually has a fixed IP address. Now it has a fixed IP address in the second Ethernet port, but it also, as of the latest firmware version, actually has a configurable IP address that you can lock the radio onto so it will always reply and you can get into the web interface for it. But that is a fairly new feature that we've just recently added to this radio. The next thing is that keep in mind that if you do have a radio configured for ether station, because the radio is cloning the device that's physically connected to it, it will actually look at the MAC address of the connected device, and then if it doesn't match to it, it'll then say, oh, that's the device I need to clone. It'll put that information in there, and then it will then, when it reboots, it'll come up connected to it. Now, the reason I want to point this out is because we are cloning devices. The ESTeem network that is running station bridges, station routers, and station masquerades will actually show up with the wireless MAC address of the radio itself. But when we're in ether station mode, or you're connecting to it with a Wi-Fi client on, say, the 2.4 and the 5.8, it'll actually have the MAC address of the connected Ethernet card. So even though the radio would be connected through ether station, it's going to show up as the MAC address of the port that that ether station radio is connected into, just so that it doesn't become too confusing. So what are some of the other troubleshooting tricks that we can do here? When we're talking about a mobile client, what a mobile client does, because it is never fixed to one particular channel, what it is actually doing is it's scanning all the available channels all the time. Now, if you are only going to be using particular channels, say it's a 2.4 gigahertz radio and there's 11 available channels, if the only two access points you have available are on channel 1 and channel 6, then you can actually allow a faster reconnect with the network to limit the radio to only scan those two channels. That is available within the advanced configuration to be able to do that. Same thing for the data rates. Based upon the distance, you may never be able to get to, say in the 2.4, we can go all the way up to 150 megabits per second. Well, if we know based upon the distance that the fastest it's ever going to go is 36 megabits per second, what we can actually do is limit, either from the remote end or the access point, the actual RF data rates that are available for it. So you can, again, what we're doing is making this much more a quick roaming capability within the radio itself. You also have the ability to adjust the access control list. So if you have particular clients that are going to be roaming around that you want them to only communicate within certain areas of the plant or certain areas across town, you can set those up to where they will only connect to certain access points. We can actually have an access control list both on the access point side and also on the client side. So you can limit from an access point to which clients you want them to talk to, and from a client which access points you want them to talk to. So what this does is it just allows you to fine tune how you want these mobile networks to work. Once we've established all of this, now that we've gone through, we've looked at, how do we mount the radios? What are the troubleshooting steps? What are the areas that we can go in and look as far as finding out how well the radio works? What do we do over the long term as far as maintenance goes? Well, a good thing to keep in mind is that overall the maintenance on these radios is fairly simple. What we need more than anything else is be able to look at how much signal strength we actually have over the radio over time. This really comes back and hits home to one of the things that we discussed in an earlier session, is the key to the need for a commissioning report. So when the radios are first put in, we need to make sure that each one of those communication links into every one of those radios is marked down by what its current signal strength is. Because what happens is if in the future, if there's communication problems, the first thing that any kind of maintenance or troubleshooting, or you get in contact with support, we're going to ask is, what is the current signal strength? Well, if the current signal strength is a -80, well, that number by itself really doesn't represent much. It doesn't tell us much of anything. Because if it used to be a -60, we have a problem. If it's always been a -80, there really is no problem. So a number by itself doesn't mean anything. It's really a number over time that really tells us things. Again, that documentation when we're doing the site commissioning is the key, because we need to look at signal strength, what is the data rate, and the actual network routing. Because it may be that we're never utilizing a repeater site, that we've put in a redundancy and we're going as an alternate path, and it's always been running that way, and it's always been not necessarily running the way you'd expect it to. So keeping in mind how these work, that is going to be a key for maintaining the system over time. The next thing that we usually recommend is at least once a year or on an annual basis, we need to do a hardware inspection, which is going to give us everything from checking the weatherproofing on the boots, the seals, all of the components within that pole mounting kit are a UV protected rubber type material. But what can happen over time is those can actually become stiff and brittle. So you want to make sure that if any of those have any kind of cracks, or something comes up, birds or any kind of insect is getting in there and getting inside of these, that we know that there is a problem and can get those replaced. We need to keep them soft, pliable, because that's what keeps the moisture out. Moisture is going to be the most detrimental thing that happens to it. And as I mentioned to you earlier, really the key to this, because on an antenna connector, what we're talking about is we're actually putting two pieces of metal in physical contact with each other. So if we have anything that gets within that, it is going to cause a signal loss, which of course we would see up here in our annual inspection of the received signal strength. With those two elements, keeping an idea of that we've maintained a good reliable signal strength, RF data rate, and that we have a physical inspection, and that we're not going to be, these radios can easily go, and many of our systems have well gone 10, 15, 20 years is really not uncommon for their operation. So hopefully you found this information very valuable. We're here to help in any way that we can possibly do this through support. We can, of course, you can call, email us, but what we want to do is make sure that you have a reliable communication network that will last you for many years to come. So thank you very much for your time through all of this.